On. Come back. We got image? Come on. Whoops. Dude, come on. Sorry, something's technical issues. Oh, here we go. We're in action now. Right. Okay, what page is it?
8.
8. Right, page 8. Any particular question? Anyone?
Just for 8.
We do
For 8.
we do A? Sure. Well, I did A in class, didn't I? Maybe we'll do B. Or which one did I give you for homework?
For 8.
Oh, sorry, I gave you for A for homework, so I'll do for A then, yeah. Right, guys, I got that page 8. Page 8 for A is what we're going to have a look at now. It was 2 over 7x, wasn't it?
Yeah.
Minus 3 over 5y equals minus 5 over 9. And then 2 over 9x minus a half y equals 5 over 7. Have I got that right? Yeah. Okay. Let's begin. So we should put this in a block. So 2 sevenths minus 3 fifths minus 5 ninths. 2 ninths?
9.
Minus a half and 5 sevenths. Now, what I'm going to do, I want to make these the same. Now, there's a few ways to do it. If you really, really dislike the fractions, you could get rid of the fractions. If you don't care about the fractions, then we can do it a little bit shorter. You all have calculators, right? So it doesn't really matter that they're fractions. So the easiest way to make these the same would be to both make them 1. We could do that. So we could just do a multiply by 7 over 2, yeah? And we could multiply this one by 9 over 2. And that's the easiest way to do this. So I know that I'll already have 1 and 1 here for sure. And then this one here, that would become minus 21 over 10, I think. Yeah, and this one would be something 35 over 18, yeah. 35 over 18. And this one here would be minus 9 over 4. And this one would be 45 over 14. Yeah. Right? So we'll do next row 1 minus row 2, putting the result on row 2. Yeah? Right now we'll need our calculators for sure. I know the first one's staying the same. Now, who's that? Ah, come on. How come you're so late, guys?
We went to the other block.
Oh, guys. So that brings me up to full attendance except for Ray, isn't it? Okay. Come on, come on. Come on.
While they were like preparing, we just got some of the lights.
Is it a bit hard to see?
Yeah.
Yeah. Do you mind getting the lights there, please? Thank you.
Oh, perfect.
Really?
Yeah.
Okay.
Is
like watching movies.
it always R1 minus R2 resolve to R2? Or is it like...
No, because well, if you're doing it the same way, that is, you're making the first column the same, then yes. It will be row 1 minus row 2 onto 2. It's a standard Okay, sorry, continuing. So row 1 minus row 2. 1 minus 1 is 0. Does anybody have minus 21 over 10 minus 9 over 4?
Plus.
Minus 51.
3 over 20? And then minus 35 over 18 minus 45 over 14.
45. Minus 325 over 6.
Over 63?
325
Yeah,
over 63.
like that?
Yeah.
Okay. Now, the next thing we'll do. So, again, well, look. Previously, we learned in class we can stop at this step, right? Because what have we got now?
Zero.
Potentially, yeah. We have our 0 and we could potentially calculate the z. But what I want to show you, and I showed the other students in the tutorial, is you can actually continue with this. So watch this. This is a little bit extra now. I'm going to, again, with the help of the calculator, multiply this by 10 over 21 and multiply this by 20 over 3. So that's not too difficult because the first one will become 10 over 21. What will this become? Minus 1. Yeah. Now we'll need to calculate the last one there. 0 and this one here? 1. So if somebody could be so kind as to multiply those, and then we'll have to multiply those. The first one is, what is it?
Negative 25 over 27.
Yeah.
Second one.
Yeah.
Negative 6,500
Yeah.
over 189. 89.
Perfect. Like that, yeah? Perfect. Right. The last thing to do, or nearly last here, I'm going to do row 1 plus row 2 and put the result onto row 1. So now I get, that's the same down the bottom. Right, row 1 plus row 2. 0 plus 10 over 21? 10 over 21. Minus 1 and the 1? 0. So can somebody add these? Minus 25 over 27 plus negative 6,500 over 89. So it'll probably be another big fraction.
Plus.
Sorry, I want someone to type in this. Minus 25 over 27 plus 6,500. Sorry, minus 6,500 over 189.
So whatever minus.
What did you get?
Negative 2225.
2225 over
63.
63, like this. Yeah. Lastly, I want you to multiply row 1 by 21 over 10. So I think it's clear what we get here first. It will be 1. And this here is minus 6,500 over 189. And then if you take this fraction and multiply it by 21 over 10, I hope you get minus 445 over 6.
Yeah.
Yeah. Now, I'm super finished because what is this first equation? X equals negative 445 over 6. And it's the second equation? Y. So you see what you've achieved? By getting the block in this form, these two numbers here represent x and y, the values x and y. Now, you didn't have to do it that much, but what I like about this method is you could keep chipping away at it until the answers appear on the right. That's the idea here. Like technically, once you got to this step, you had enough to figure out the answer because this could easily give you the y. In fact, actually on the previous step even, you could get the y here and sub it in to get the x. But even less work now, you have the full x and y complete here. So It's kind of nice to see that. Okay. So when you look at this, how many steps? This here was just the question, wasn't it? Yeah. 1, 2, 3, 4, 5 steps to the answer. But what's nice about this method is it's pretty much the same 5 steps every time. The only thing that might change would be the multiplication numbers and whether or not you add or subtract. Why did I add the rows together here? Well, because the sign was already opposite, you know.
Why do we like the first row and then work with it, and like then we leave the second row and work with it? How we decide how it helps us and why is it left?
There's no, it's more just a common structure. There's more than one path to the answer. So it's not like this is the only way to do it. But what you're trying to do is you're trying to zero this guy first, make this a 0. And the way to make this a 0 easily is by making the first 2 x's the same. So one could subtract the other. Then what you try to do is 0 the top guy. And again, you can do something similar by making these 2 the same. And what's nice is you don't have to worry about this guy because it's already a 0. And even if you multiply it or add it, it doesn't. It's not like it can come back to life as a different number. It's just usually the pattern we follow. But you don't have to do it this way. You know. But keep in mind, it's usually first make that 0, then make that 0.
I just like, why don't we like put the like 0 that we're like added in the new, not, and why we are putting the previous row and then continue to use the first row, for example.
So the rules are with the Gaussian method is if you combine rows, the answer must go on one of the rows.
One of them.
Yeah, one. But in fact, it could go on either of them. You have flexibility. So you could have done row 1, row 2, answer onto row 1.
And then use the second one, but we like decide which one is more
Convenient.
Yeah.
Yeah, you have a lot of flexibility. You're allowed to multiply by any number except 0. And you're allowed to combine any 2 rows in any way you want by adding or subtracting. But you must put the result on one of the rows. One of the rows must be replaced by the answer.
Anytime, yeah. Any amount of time we can multiply.
Any, no limit, yeah. Yeah, no limit.
So no possibility to get a mistake.
Well, the more operations you do, the more likely it is that you will make a mistake personally.
Yeah, I mean like to go into dip, not
Yeah. But to answer your question, you can take any number of steps. 5 seems to be the least, I think. Okay, what else do we need to see? So Gaussian, I know, was something people wanted to see from last week, I think. What about recently? Yeah, which page?
20.
20, okay. Which number?
A, 3A.
3A. Yeah, discriminant. That's what it is. Correct. Congratulations on your reading ability, Nikita. 3A. 3A? Yeah. Okay. Right. 3A. Was this a homework question? Yeah?
No.
The homework was like B, D, E, A,
Oh, okay. Do you want me to do 3A or a homework question? Your choice. It doesn't really matter too much. What letters did I give you?
B, C, E.
B, C, E.
No,
Okay.
No, 2 B, C, E.
No, I'm pretty sure it was 3 B, C, E. Yeah.
Me? Oh, I feel the opposite.
Yeah. Well, is the problem question 3? That tricky. Right. So the reason I gave you probably have spotted, why did I give you 3 B, what did I say? BCE? Are you sure? Really?
No.
Not BDE?
No.
Oh, okay. BDE would have been better.
Okay.
Right.
Okay,
Doesn't matter. I shall do as an example 3b. Anyways, 3a and 3b are the same type of problem. They both are what's one distinct root. In fact, there's very little difference between them. So let's just do 3b since it was a homework question. So I said minus k plus 4 x squared plus 2k minus 4 x plus minus k plus 4 has one distinct real root. What is the discriminant? Equals 0. Yeah. Yeah. Smooth. Nobody noticed. Yeah. Right. You definitely weren't going to say less than 0. For sure. Right? Equals 0. Okay, so what's the b here? 2k minus 4 squared minus 4 ac, yeah. Oh, that's kind of nice, maybe. That they're the same. Is it nice? Ah, it's interesting. Okay, let's expand this. 4k squared minus 16k plus 16, correct?
Yes.
And then when we expand this, it will be minus 4k squared, 32, triple minus 32k,
Yeah.
Plus the
minus 64.
Is it minus 32?
Yeah.
Is it minus 32? Good
I know
question.
it's minus 64, but
I think it's plus 32.
Yeah, plus 32.
Plus 32, yeah. Because I multiply minus k by minus k is k squared, by minus 4 is minus 4k squared. Then what's that? That's minus 4k, minus 4k is minus 8k, times minus 4 is plus 32. And then 4 multiplied 4 is 16 times minus 4, minus 64. Okay. Oh, look, they cancel. 32k minus 16k is 16k.
Yes.
Six,
Minus 48.
minus 48. I take it to the other side and I get 48. So then finally divide by 16. 3 it is, yes. So 48 over 16 is 3. Okay. Yeah. That was B. Write that down if you need to. Right. What else do we need to see?
Can you have another example?
Of this one? Absolutely. Do you want the same type, one distinct root, or a different type?
Different
Different? It doesn't, yeah. Or like, for example, will I do D? Yeah, let's do D, because that was a homework one, wasn't it? Yeah. Well, okay, whatever. Let's just do D. D. Minus 9k minus 9 x squared plus 6k plus 6 x minus k has two roots. So the discriminant more than 0. Bigger than 0. Okay. B squared minus 4ac more than 0. That's the A, that's the B, that's the C. Right, we'll expand the first one here. So 6k squared, 36k squared. And then twice the first by the second, 72? 72k? And then 6 squared? 36. Now, what's wrong? Did I do something wrong? I wrote minus? Minus 9? Is not minus 9?
Oh.
Hang on, just before I continue. What number do I have wrong?
No, I'm asking.
Yeah.
expansion of this, how did you go about it?
Oh yeah, okay. So the 6k is it?
SMS.
What?
Square. Square multiply square.
Yeah. Watch, guys. Watch. Excuse me. You're the one asking for this, so you should be watching, right? Not talking. So, if you have a plus b squared, the quick answer is a squared plus twice ab plus b squared. Okay? So here, the first squared, 36k squared.
Square.
Yes.
72.
And then 72, because it's twice 6 by 6. And then finally, 6 squared. Okay, are we happy with this? Alright, now look, let's multiply out the second one. So, minus 4 multiplied minus k is 4k. And then 4k multiplied by minus 9k, minus 36k squared. And then minus 4 multiplied minus k, again, is 4k. And 4k multiplied minus 9, minus 36k. More than 0.
It cancels again.
Yes, it's like whoever made these questions designed it that way.
They go backwards.
Huh?
I don't know.
No, actually, I made a computer program make the questions so that the quadratics, the squares always cancel. So that, now it only happens in my workbook because I wanted to make the questions a little easier for you since you're always end with a linear. So 72k minus 36k is 36k, isn't it?
Yeah.
And then it's just the 36 here. Bring it to the other side and you get minus 36. So finally,
Minus 1.
minus 1.
So, but
Oh, yeah.
if the k square is not cancelled.
But don't worry, because I designed the question so that they will cancel. And we haven't learned what to do if they don't cancel.
Okay.
You see, this is a carefully designed workbook.
But there will be 2 answers.
Yeah, but you see, you're worrying. Don't worry about it. We'll deal with that on a later lesson. Page 26, I think, anyways, this one, it might come up. No matter. Right, so, what do we need to see next now?
Page 18, question 4 and 5.
18.
So before that,
4 and 5. So how about I do 5 as an example? It's the same idea, yeah?
do we call the k more than minus 1, do we call value or range?
Give me a sentence.
Like
You would say what?
range.
Yeah, but give me a sentence. Like, you're going to say the answer is, or like, how are you going to use it is my question.
Okay, like find the range of keys.
Okay, yeah, so you want to know how would it be in a sentence for a question, for
Yeah,
example,
question.
yeah. You know, it could be both, because you could say find the possible values of k, or you could say find the range of values of k. I don't know, could you say find the range of k? I'm not sure. I think I would see most questions perhaps say find the possible values of k or find the range of values. I think range of values would be the most common way of saying it, yeah. I'd have to check. Yeah. Okay, sorry, what, page 18, number 5 now. Yeah?
Yeah.
Okay, so I think some of you maybe got this, and some of you had some trouble. The trick to number 5 is the same as the trick in number 4. And what is that trick? It's what's called a substitution. You say let, in this case let u equal
X squared.
x squared. And so, what would u squared equal? X power 4. Yeah? So you can change this problem into this problem.
The word
Yeah, that's it.
Probably we could even divide by 36.
Could we? Does
Yeah.
36 go? No, 36 doesn't go into 145.
Yeah, but it still will be like a bit nicer.
Fraction here? Nah. If we really are too tired, we can just use the formula.
Yeah.
Yeah, because there's no way I'm going to try and factorize this. Or could I? Let's see.
No, it will be harder for.
No, let's try and
for
do
easy
it.
discriminant.
Let's try. Okay, fine. Formula. Right. U equals. Oh, I remember.
The only point of dividing is when you want to use Vieta, when you're guessing the.
Hang on. Let me think. 100. Don't tell me now. I can do this one. 145 squared minus 4 times 36 times 34 is 289 over 72. And the square root of 299 is, don't tell me, 17. So it's 145 plus or minus 17 over 72. Okay. I can only do the hard ones, not the easy ones. Right, 145 plus 17. You see, now that's actually harder for me to do. That's 162. Yeah, you see, the small ones are hard. Right, and then or, with the minus 1, 128. Yeah? No. Guys, come on. Give me a break here. 145 minus 17. Too tired to do that in my head. I used all my brain power on the previous part. Oh, don't make me do it. 127, is it?
This?
Yeah, well, it simplifies down, so that works out to be 9 over 4. And the other one?
16 over 9.
Is it 138?
Thank you. Your subtraction is better than mine. Is anybody curious to how I got the 289 so quickly in my head?
Yes.
Yes. So what you could do, I spotted there's a trick here. It's b squared is 145 squared, isn't it?
Yes.
Minus 4 times 36 times 144, isn't it? Now you can easily do 4 times 36, it's 144, because you multiply 36 twice by 2. 36 doubles to 72 and doubles again to 144. What's 144 by 144? 144 by 144 is 144 squared. Now, when you have a difference of squares that are neighbours, that's easy to do. Because remember the formula for difference of two squares? X squared minus y squared is x plus y times x minus y. But what's x minus y here? 145 minus 144 is just 1. So this is the same as 145 plus 144. And that's easy to do in your head. Because all the digits...
Okay, it goes to 89. Lol.
Yeah. So, this is where the harder one is easier to do here than the easier one. Right, so we're down to this step. But this isn't x. What is this? This isn't the answer for x.
Oh, this is like
It's for u, which is x squared. So, you have one thing left to do. Yeah, well, what's the last thing to do? Root. Now, just be careful. It's plus or minus
1.3
3 over 2. Yeah, or 4 over 3. Okay.
So there is 4 answers.
4 answers, correct. Yeah. Okay. You got that? I don't think for the semester 1 exam, semester 1, it's really unlikely that you would get a question like this for semester 1.
I
Okay.
don't want easy questions.
Huh?
I don't want easy questions in the first semester.
You want hard
No,
questions?
I don't. Because at the same time, it's like you get confused when it's too simple question. You start to
No,
overthink.
don't worry. I have students who get too confused on both the easy and hard questions. So there's plenty of confusion all round for all levels of difficulty. This is a little bit too difficult. No, it's too difficult for a semester 1 exam. Now, sometimes in semester 2, you might get a question that requires some kind of substitution like this. My experience, though, is the substitution is always obvious. It's always very obvious here. Yeah. We haven't seen it yet, but this idea of a substitution comes back later. So in a later lesson, we'll see something like this. Sine squared theta, plus sine theta plus 1 or whatever. So don't worry, we'll do this later, but what's the substitution here?
Science.
Sine theta, But again, that is something we'll see later. Oh, poor Aziz, is it? He's so tired. Why so tired?
I'm a bit sick.
You're a bit sick,
Yeah.
but you came to maths class anyways.
I can't skip that.
No, good man, right. Are you feeling sick?
Yeah.
Is this your last class today?
Yeah.
Okay, so just struggle on for 5 more minutes and then you can go. Yeah.
There's a question, I got confused in it.
Is this an example from class or from the workbook?
Both.
Okay.
See here in the elimination, we said that we multiply 3.
Yeah.
3 here.
Yeah.
And 2 because
Mhm.
the-
Yeah, good.
Then, when I multiplied here by the same number, I got a different answer.
Can I see the question again?
No.
So you multiplied this by
4.
4.
Yeah.
Good. And this?
I multiplied by -4, not 4.
Fine, yeah, -4. Good. And then this one by 7. Good. And they cancelled.
Yeah.
Good. So this is the
But-
answer.
But you said like, multiply them like without.
This now.
No, you see, that's a choice. So a lot of students prefer to multiply by the -4 and then you add them together, right? What I prefer to do is multiply by the positive and then subtract them. This is why it might look different.
And here I got 2 and here I got -2.
I think you made a sign mistake doing it this way. Because you probably didn't subtract, you probably added the lines.
No,
Oh, you did? Did you?
no, 4 times.
Okay.
And minus
Are you looking at
Is that
32 minus 21 is 11.
32 minus... Ah, but you're supposed to subtract them, isn't it? So shouldn't it be 32 minus 21?
Yes.
32 minus 2.
I have animal in
Yeah.
So minus
Can
1.
you look at
Yeah.
But
But then here, it'll be 20 minus 42, which is minus 22. Maybe something went wrong in the earlier one. 7. And you multiplied the first one by minus, did you? Yeah, that looks okay. And then you added them together. Ah, no. Mine's right. Yours is wrong, I'm afraid. No, wait, hang on. I think you're right. Sorry, no, you're right. Okay.
no, I know this one is right. I
Yeah,
checked the
yeah,
answer.
yeah.
But I multiplied by,
So you want to know what went wrong here?
yeah.
7.
Right, 28, 32, 20, correct. 28 minus 21, 42, correct. And then we're minusing them. 28 minus 28, gone.
No, people call me.
32, it should be minus 21, yeah.
Listen,
Can I have David?
It's manual.
Actually, 32 minus
Yeah,
and 1,
you bring it underground.
53.
53.
It's not 11.
No, well hang on, something's gone strange
Ah,
here. I tell you what, I can't see what's going on. I'm not. Oh, you copied it wrong. This is 7x minus 8y, and here you wrote 7x plus 8y. That's the reason for the problem. Here you go. Try again.
So now, always, for example, the there's now here is for example negative. So I multiply it by -4 and here 4.
If you want, well, no, it's your choice. You can either multiply by both positive and then subtract them, or maybe you prefer to do what I did here, or you did here, is multiply one of them by a negative and add them. It's your choice. Which do you prefer?
No, I mean if there is here negative and -4. So I still multiply both of them.
Yeah, that's fine. Yeah. Okay. Okay. There might be time for one last question. What do we want? Oh, you're going to get sick. He's going to spread his germs on you. Is he? Right. What do we need to see? Nothing more? 20. Sorry. One more coming. 20. Which one?
2B.
2B. Okay, let's just have a look. We'll do one more, and then you can go on your weekend. Okay. Right, which one? 2B? 20, 2B. Minus k, x squared, plus minus k plus 9x plus 3. Now, come on, if you delay me, you're actually delaying yourself. If you think about it, you know? Yeah. Ancient Eastern wise saying, you know, delay the teacher, delay the student. Yeah. Okay, now, continuing. There's one thing I know about the value of k before I even start. What value of k do we know is off the table that we can't have? K could not be what value? 0. Why not? Yeah, well, yeah, something a little bit else perhaps. Why am I saying k is not 0?
Oh, because it's negative.
Oh no, come on guys, why is k not 0? No, it'll still be something. It'll be a linear. Yeah. Why can't k be 0? Because it won't be a quadratic then. Oh, come on guys. Right.
Because
So,
it is mentioned in the question.
yeah, the question says in each quadratic.
Makes
Yeah.
sense now.
It's in fact, it also says in the question that it's non-zero. Yes, okay, so also a key reason why. Okay, so let's see what we have here. Discriminant is minus k plus 9 squared minus 4ac. Isn't that right? Yeah. Let's expand this. That's k squared minus 18k plus 81. No, 81. Isn't it?
Yes.
81 plus 12k,
Yep.
which is k squared minus 6k,
Plus 81.
which is the same thing as k minus 3 squared plus 72. And I know that absolutely must be a positive. In fact, not only do I know it's positive, I know that it's at least 72 or greater. So I'm guaranteed that this quadratic will have 2 roots.
Yeah.
Real.
2 real distinct roots, yeah, for sure. Okay, so what that is saying, no matter what value of k you pick, so for example, let's say you pick some random value, e.g. k equals 2. Then the quadratic minus 2x squared plus 7x plus 3, how many roots will that have? I know it's guaranteed to have 2. No matter what value of k you pick in this quadratic, you know that it will have to have 2 roots.
Of course.
Makes sense.
So,
Doesn't
is
it?
it 2 real distinct root or distinct root?
It's 2 real distinct roots. I'm just saving my energy and saying 2 real roots.
No. And then why in the question 3? Like 3a. At the question A
Yeah,
has 1 distinct root.
yeah.
Ask you to name.
Why distinct root? Isn't it real distinct?
Oh yeah.
Oh, it's a grammar question.
Oh.
I don't know.
I think you could do both.
And this
Okay.
Yeah. I won't take any marks off you in the exam for bad grammar. Don't worry. All right.